Hello everyone. Today we're going to be talking about order of operations. Now when you think of order of operations, first you might wonder what is an operation. You can kind of think of that as like an addition, subtraction, division, multiplication, and so on. All these interactions that we have with numbers, we call them operations. Now when you have a line including several operations, there's a certain order that you should be doing it in to make sure you get the correct answer. If you don't follow the proper order, your answer will probably be wrong. So when looking at order of operations, we can remember the saying PEMDAS. PEMDAS stands for the order that you should be solving these problems in. P for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. Now there's a lot of different combinations that we can get of PEMDAS, so it's good just to start with some examples that lay some groundwork for us. So let's look at addition and subtraction, since this is probably the most straightforward of the bunch. Say we have something like 5 plus 2 minus 6. When it comes to addition and subtraction, it doesn't matter in the way you do it because they're commutative, which just means that you're going to get the same answer no matter what way you do it. So you can do 5 plus 2 minus 6, so you can do 7, then minus 6 equals 1, or you can do 5 plus 2 minus 6, 5 plus negative 4. When you add a negative number, it just means you're subtracting it, you get 1. So you can see that no matter what we do, addition and subtraction, we're going to end up coming with the same answer by the end of it. So we'll call this our first example of PEMDAS. Now our second example is where you're going to start to see how answers can vary and why it's important to understand how PEMDAS works. So let's work with division and multiplication first. So I mean division and then multiplication in the order that everything is going. So let's say we have 3 divided by 3 and then multiply that by 6. You can have a dot for multiplication or you can have an X. I'm just going to use a dot for simplicity's sake. So let's say we do 3 divided by 3 first. So we're going to have 1 and then multiply by 6. We're going to have 6. Now that's the correct way to do it when it comes to division and multiplication. You want to work left to right. Now, if you're going to be doing it the other way, you're going to get 3 divided by 3 times 6, which would be 18. And you see you're going to come out with 1 over 6. And 1 over 6 is not the same as 6, so you want to make sure that you're doing it the correct way. Otherwise, you can get this difference in outcome. Now, let's say we have multiplication and division. Let's look here. So we can say 14 times 2 divided by 4. So let's work from the left. We can do 14 times 2, 28. Divide that by 4, that's 7. But you can also do 14 times 2 divided by 4, which is going to be 1/2. Multiply that out, and that's going to be 7. So you can see 7 is equal to 7. So it means when it comes to multiplication and then division, it doesn't matter what order you do it in. But if you're going from division to multiplication, you want to work left to right. So a good rule of thumb, and you can apply this to addition and subtraction as well, is work from left to right. That's going to give you the correct answer most of the time, especially if you're being careful. So it can definitely get confusing when you're working with multiplication and division. If you can't remember which order that you can go in with them, just go from left to right. Just play it by default, play it safe. So let's look at some mixes of these examples that we learned with addition, subtraction, multiplication, and division. Say we have 7 times 3 plus 4. Now I'm going to rewrite PEMDAS for us so we have a good reference point moving forward. So using PEMDAS, let's look here. We see we don't have parentheses, we don't have exponents, but we do have multiplication. And we also have addition in here, but you can see that multiplication comes before addition. So what we're going to do first is 7 times 3, which is 21. And we saw plus 4 at the end, that comes out to 25. So that is the correct way to do it. Now if you weren't to do it the correct way and you did 3 plus 4 first, you're going to get 7. And 7 times 7 will be 49. You see 25 and 49 are completely different answers, which expresses why it's important to understand PEMDAS. So we're just going to keep going through these examples one by one, getting comfortable with this a little bit. So let's say we got 8 divided by 2, let's look here. 8 plus 2 times 3. Okay, so we know that multiplication will come before addition. We just looked at that. So we're going to do 2 times 3 first, which will come out to 6. We still have to add that to 8. 8 plus 6 is 14. If you were to do it the other way, we would have 8 plus 2, which is 10, times 3, which is 30. 30 and 14 are different from each other. Let's look at another one here. 2 plus 6 divided by 2. We know that division comes before addition or subtraction. So we're going to do 6 divided by 2 first. Add that to 2. 2 plus 3 is 5. Okay, let's move on to another example. We got 4 divided by 4 plus 1. We know that division and multiplication come before addition and subtraction. So 4 divided by 4 is 1, plus 1 is 2. If you were to do it the other way, you have 4 divided by 5, which is 4/5, which is not the same as 2. Let's move on to some more examples here. So you have 5 plus 6 minus 4. When it comes to addition and subtraction, it does not matter the way you do it, but we can default going left to right in case you do forget that fact. So 5 plus 6 is 11. Subtract 4, that's 7. So we got for this example 4 divided by 2 times 5. Now when it comes to this, you want to work left to right because you have division and then multiplication. But if you can't remember that, just default left to right. So 4 divided by 2 is 2 times 5 is 10. If you're going to do the other way first, you would have 4 divided by 10, which is not the same answer. And then let's do one more example. We have 24 divided by 8. And then let's do plus 2. So 24 divided by 8 is 3 because division and multiplication come before addition and subtraction in PEMDAS. And then plus 2 is 5. If you were to do it the other way, you'd have 24 divided by 10, which is not the same. And now we're going to get to another part of PEMDAS, which we're going to put back up here, just so we have something to reference. We're going to look at exponents. This is a part that people tend to get confused at, so definitely important to pay attention here, as you'll see exponents as you go. We're going to draw some basic examples to understand why these seemingly similar phrases are actually not the same. Okay. So looking at this, we know that 4 squared is 16. Negative 4 squared with the negative inside the parentheses is 16. Because negative 4 times negative 4 is 16. Negative times negative is a positive. However, if you have this negative on the outside and then you square a number, there's no parentheses involved here. You could maybe parenthesize the 4 if you wanted to and keep the negative sign on the outside. You're going to get negative 4 squared, which is negative 16. Now, if you were to square negative 4, or have negative 4 squared, that would be 16. So it can be slightly confusing, but if you're not seeing this parentheses here, then you're probably going to be dealing with a negative outcome. But typically in future examples, it's going to be a lot more clear. This is a common misconception, and typically you can write off as sloppy work if someone that's writing out an equation actually doesn't specify this. So in the future, just keep that in mind. But this is a good saying to keep in mind, that x squared is not the same as x squared. And that just comes from all these negatives here. So just keep that in mind. Although at face value it might seem the same, these negatives can definitely affect how that outcome actually comes about. So we're going to be looking at some exponents now. Keep PEMDAS in mind while we do all this, and we'll walk through with it. So say we have 2 to the thirds divided by 2. Now you're not going to do 2 divided by 2 and then to the third. You're going to look first at this exponent. Next to parentheses, exponents is one of the first things in PEMDAS, so we want to make sure we treat it in that order. So we got E for exponent in PEMDAS. We're going to have 2 to the third, which is 2 times 2 times 2. We're going to have divided by 2 still from up here. 2 times 2 times 2 is 8. Divide that by 2. And you're going to be looking at 4 as an answer. Let's go on another example here. Let's say we have 2 plus 5 squared. We know that addition comes after the E in PEMDAS, so we're going to want to focus on doing the exponent first. And let's look here. We're going to have 2 plus 25, which is 27. Okay, we're going to have 3 squared times 2 plus 5. So here we're implementing 3 different parts of PEMDAS. We got exponents, multiplication, and addition. So it might start to get a little confusing here. But we do know that exponents comes before all of this in terms of PEMDAS. So we can do 3 squared first, which would be 9. We'll have times 2 down here, plus 5. And we know that multiplication comes before addition and subtraction. So 9 times 2 is 18. And you're going to have plus 5, you're still bringing down. 18 plus 5 is 23. And then let's look at one more for this. 4 plus 3 times 2 squared. So this is where we're going to see PEMDAS shine a little bit. Because if you don't know PEMDAS, you might go from left to right. You might do 4 plus 3 and then times 2 squared. You might get 28 as an answer. But that's not necessarily correct because we're supposed to start with exponents according to PEMDAS. So 2 squared, that's 4. Bring down the rest of the equation. 4 plus 3 times 4. And now we know that multiplication comes before addition. So let's make sure we do 3 times 4 before we look at adding anything. So we're going to have 4, we're going to bring that down, plus 3 times 4, which is 12, which comes out to 16. So this is where you can see that PEMDAS stands out quite a bit. If you didn't understand order of operations, you would do 4 plus 3, which is 7, and then times 2 squared maybe, which you would come out with 28, and that's completely different than 16, and pretty detrimental if you don't know where to go from that. So now we looked at exponents, let's move on to the first order of business in PEMDAS, and that would be parentheses. Parentheses is something that is very important to understand when it comes down to order of operations, because if you don't understand PEMDAS, you don't understand parentheses, you're going to do some steps incorrectly, even if they seem like you might be doing them correct. And we'll look at how those examples come into play. It makes a little more sense when you see it. So let's say we have 3 parentheses 5 plus 2. Now looking at this, you might think to do multiplication maybe and then add in, and that would be a big misstep. What we would want to do first is what's inside the parentheses. So when we say P, parentheses in PEMDAS, we mean solving what's inside of the parentheses. So let's look, we got 5 plus 2 inside this parentheses. Okay, 5 plus 2 is 7. I still like to write that in parentheses just to make sure that I know that's where it came from. And we're going to have 3 times 7. When you have a multiplication by a parentheses, you probably won't see a multiplication sign like this. We'll probably see how it's wrote at this top first, but I'm just going to do that for clarification purposes. 3 times 7 comes out to 21. Now another way you can do this, and this is called distributing into the parentheses, is this way. When you have something inside parentheses like this, we can say 3 times 5, which would be 15, plus 3 times 2, which is 6. So that's an important factor that might come into play later as you go with algebra, but for now you don't necessarily have to remember it, but it can be definitely handy, especially when we're solving kind of complex equations. So that's called distributing your outside factor here into the parentheses. So let's look at some further examples of parentheses. Let's say we have something like 3 times 5 plus 2, like above. But we're going to say squared. So now it's important to understand how a parentheses operates. A parentheses is basically grouping a set of operations. So we can keep our 3 times on the outside. Let's solve what's on the inside of the parentheses first as we look like. Then have the squared up top. So we know 5 plus 2 is 7, keep that in the parentheses. We're still multiplying that by 3. And the squared is attached to the parentheses. So the parentheses takes a group of operations and treats it as one entity, basically. One thing, one object. So everything that happens inside of the parentheses needs to be squared by the end of it. You can square that at the beginning, or you can square that at the end. Whatever seems to be more convenient, and you'll learn that as you go too. But the important thing is that this squared applies to the entire parentheses. So we know that 5 plus 2 comes out to 7. And then we know that we have to square that. Exponents comes before multiplication in terms of PEMDAS. 7 squared is 49. We're going to have 3 times that. 3 times 40 is 120. And then 3 times 9 is 27. We're going to come out to 147 as an answer from this. So if you weren't to follow PEMDAS, you could have easily misstepped on that example and just got it wrong by the end. So let's look at some examples further that are going to be more complex. So let's put our PEMDAS up here as a reference point for future problems. Then let me look at extending this page a bit. We're going to get into some of these examples right here. Okay. Give me a second. We'll write out one of these, and then we'll talk about it. Okay. So there's a lot going on here, and it can be easy to get intimidated, especially if you're not that practiced with PEMDAS. But the key is to take it one step at a time, do one operation at a time. As you get more used to PEMDAS, you might be able to do several steps in one line. But when you're starting, I'd recommend going line by line. And if you make a mistake, it'll be easy to backtrack where you messed up. So we know in terms of parentheses, we got P. Well, PEMDAS, we got P right away, stands for parentheses. And we do have a set of parentheses here, so let's focus on doing that. 4 plus 1 is 5. Let's copy down the rest here. Okay. And then the next one would be exponents. We do have an exponent here. We got 5 squared, which is 25, is 5 times 5 is 25. And now we're at multiplication and division. Now we know you don't have to think about it, but we can work left to right in terms of these. So let's have 25 plus 4 divided by 2, which would be 2 times 5. So we're going to have 25 plus 2 times 5, which is 10. 25 plus 10 is 35. So working step by step in these problems can make it not that daunting and make it slightly easier for you to solve. So let's look at another example here. We want 3 times parentheses 1 plus 1 squared, then divide by 4 plus 2. So let's look at our PEMDAS here. We know that parentheses come first. We're going to have 3 times 2 as 1 plus 1 is 2. Let's square that. Divide by 4 plus 2. We know that the second part of PEMDAS is exponents, and we do have a set of exponents. So we're going to have 3 times 2 squared, which is 4, divided by 4 plus 2. We know that when it comes to multiplication and division, or division multiplication, we can work left to right as a safe rule. 3 times 4 is 12. Divide that by 4 plus 2. 12 divided by 4 is 3. Plus 2 is 5. So we've got a good example of showing how taking it step by step in PEMDAS will help you. So don't get overwhelmed when you see too much. Just take your time when it comes to it. So now let's look at some further examples to solidify our practice with PEMDAS. We're going to have 2 times parentheses 3 plus 1 all squared times 3 parentheses 2 plus 1 all squared minus 10 divided by 2. Okay, so we got a lot going on here. So let's write down PEMDAS for us to understand what order we're working at here. And we're going to do a different color because we got a lot going on here. So we know that first we're supposed to work with parentheses. And we've got 2 parentheses here, so we can kind of do them at the same time. So let's do this. 2 times 3 plus 1, that's 4. We're going to leave that all squared. Times 3, 2 plus 1, that's 3. That's going to be all squared. Minus 10 divided by 2. We know that the second part of PEMDAS is E, which is exponents. And we do have exponents, so let's do that. 2 times 4 squared, that's 16. Times 3 times 3 squared, that's 9. Minus 10 divided by 2. Okay, so let's look here. Now we know all we have basically is multiplication, division, and subtraction. So let's start with our multiplication and division. As you know, that comes before addition or subtraction. 2 times 16 is 32. And then let's say times 3 times 9 minus 10 divided by 2. Okay. Keep going with this. We're going to have 32 times 3, which would be 96, times 9 minus 10 divided by 2. Now let's look at the other side, as that might be simpler. We got 96 times 9. We know before subtraction we're going to have to do this division over here. So we're going to have 10 divided by 2, which is 5. Now when it comes to 96 times 9, let's see here. We're going to have 810, which is 90 times 9. And then 6 times 9 would be 54. Add that up. We're going to have 864. And then we have to subtract that by 5. And that comes out to 859. So you can see how working one at a time with all these examples really does help. Just keep in mind PEMDAS as you're working through these. Go from left to right in terms of PEMDAS. Multiplication, division, if you can't remember, go left to right. Otherwise, just go through this video a couple times to practice with it, and it should all come into place eventually. Feel free to like the video, subscribe, share with your friends, comment on it. I love to interact with you guys. Otherwise, I hope this video was informative and helped you with your algebra. Bye.